Good morning. What we want to go ahead and talk about today is indirect measurement. We're still dealing with proportions. And what we're going to talk about is figuring out whether or not images are similar or not. And then what we're going to do is we're going to determine the length of a missing side, all by using proportions. Okay, so let's go ahead and get to it. Here we have triangle ABC, and we have triangle DEF. What we need to determine is whether or not these two triangles are similar in size. And what similar means is they're the exact same shape. You can see that angle B and angle E have the exact same angle measure, and angle A and angle D have the exact same angle measure, and angle C and angle F have the exact same angle measure. The only difference is one is either larger or smaller than the other. So that's what similar means. The exact same shape, exact same angle measurements, just different sizes. So in order to figure this out, this is how I like to do it. I like to make sure, first of all, I need to make sure that these triangles are both pointing the exact same way. That means if this angle here that has the three little bars is on the right side of this triangle, this angle with the three little bars is on the right side of this triangle. And since they are, and since they're both pointing the exact same way, I can go ahead and set up a proportion. If not, I would have to do just a little bit more work. So what I'm going to do is I'm just going to draw a line right between two numbers, okay? I drew a line between the 4 and the 8, and I'm going to draw a line, a similar line, on the similar triangle that happens to be between 6 and 12. Now what I'm going to do is set that up. I have my proportion pretty much set up. So I'm going to say 4 over 8, and I have 6 over 12. What I need to do right here is I need to cross multiply, and if my values are equal, that means these triangles are similar. 4 times 12 is 48. 6 times 8 is 48. So the answer for this is yes. These triangles are similar. S-I-M, similar. All right, that's what we're trying to determine, whether or not these triangles are similar. Now, we have triangles in our second case here. They're pointing the exact same way, but the problem with these is, and we can tell they're pointing the same way because I have my angle with the two lines up here and my angle with the two lines up here, and so you can see that they're pointing the same way. It's understood, excuse me, that these triangles are similar. Okay, that's the cool little symbol for similar. Remember, mathematicians, we're lazy and we like to use symbols as much as we can. So it's understood that these triangles are similar, but what we need to do is we need to solve for the missing variable. Okay, so this is all I'm going to do. I'm going to draw my line like this and draw my line like this. So I can set it up as 6 over 15 equals 4 over x. Now I just cross multiply and solve just like we have been doing with proportions. 4 times 15, I go ahead and I get 60. And that's going to equal 6 times x, which is 6x. I divide both sides by 6, and x will equal 10. And that will be my answer. So now we figured out the length of the missing side. All right, let's go ahead and talk about two images that may not be pointing the exact same way. All right. So first thing we need to do is we need to understand the characteristics of a rectangle. All right, and to understand the characteristics of a rectangle, obviously it has 4 right angles. Okay, now, and it has 4 sides, obviously, but the thing that we need to understand is that opposite sides are congruent. That means this side that is labeled 5 is the same as this side that is not labeled. This side that is labeled 12 is the same as this side that is not labeled, okay? And on this image as well, okay? If this side is labeled 4, then this side is 4. If this side is 11, this side is 11. So what I want to do in this case is I want to go ahead and turn basically this rectangle so it's the same way. If I'm going to compare my sides, okay, then I need to go ahead and have it pointing the same way. It would be incorrect if I set up, and I'm just writing this down so you see it and understand. It would be wrong if I said 12 over 5 equals 11 over 4. That's not right, okay? Well, it would be incorrect because we would be basing it on this way. What I want to do is I want to draw this rectangle like this, have my side labeled 11, this side labeled 4. What I actually said was correct, but I want to make sure that you understand why we're setting it up the way we're setting it up. So now I have 12 over 5. And I know I said 11 over 4 wasn't right, but now that we have it written and we can see that it's 11 over 4 and why it's 11 over 4 and it's correct, now I would accept it, 11 over 4. So yes, you must draw this image. If I don't see this image redrawn, if they're not pointing the same way, then it will not be correct for you. Okay, so now I just want to see, are these rectangles similar? So 5 times 11 is 55. 12 times 4, that's 48. And we can honestly say, no, they are not similar. All right, they're not similar. Okay, let's go ahead and take a look at the next set of triangles here. Now this is where we really need to make sure that we're seeing this and we're lining it up so it's exactly right. So I'm going to draw this little triangle here. I'm going to redraw it just like the big triangle, okay? So I have it like this and this and this. Does that make sense? Okay, I'm going to put my right angle in. Now, this side that goes between the right angle and my double line, okay, see I have to have my double line there, and then I have my single line here. So this side that goes between the right angle and the double line, I'm going to label that 1.5. Okay, now the side that goes between the right angle and the single line, the right angle and the single line is 3.6. And this line right here that goes between the single line and the double line, the single line and the double line is 3.9. Okay. So now what we have is we have two triangles that we can compare. Now it might be confusing to you to say, okay, Miss Askew, I see triangles. We're not even going to use this, by the way. Sorry. Let's cross that out so that doesn't distract us. And you might say, Miss Askew, these have 3 different numbers on it, so which ones do I use? Okay. I'll be honest with you, you can draw your line here between the X and the 6, or you can draw your line here between the X and the 6.5. Whatever you draw the line between on this triangle, you just have to draw it between these on the other triangle. Okay, so I'm going to use X and 6.5, so X over 6.5 equals, and 1.5 over 3.9. 1.5 over 3.9. Now I'm going to cross multiply and solve. And this is where you will need a calculator to use. So 1.5 times 6.5 equals, and I got 9.75. I hope you got the same thing. If not, just let me know in class. And 3.9 times x is 3.9x. Now I'm going to go ahead and divide by 3.9. Sorry, I was just double checking my numbers. I want to make sure that they're reasonable numbers and that they're not all crazy. And some of you might be saying, well, the x is in all different places when I set up my proportions. And that's okay, as long because we're always just going to divide by the number that's on the side by the variable. And 9.75 divided by 3.9 is going to be 2.5 is what the value of x is. Okay, so let's practice just a couple more. Looking at this figure, you can use indirect measurement to determine the height of a statue. Okay, that's what this is showing. There would be a lot of words attached to it, like Johnny wanted to know the height of the statue, and he created a triangle that was 5 foot high. He was 5 foot high and distance of 6 feet away, and to determine the height of the statue, which was 30 feet away and h feet high. So you can go ahead and determine your proportion, set up your proportion, and solve that one. Okay, if you need to, pause so you can work on that. I'm moving on to this one because this is another real-world situation, okay, where we have two triangles. Are they pointing the same way in this problem right here? Hopefully you said no. So what I need to do is I need to redraw the triangle. So I'm going to go ahead and redraw. Now the problem with this is it doesn't have our angles labeled. Okay, do you see where the angles aren't really labeled here for us? So we're going to have to try and figure this out. All right, so these angles are the same. All right, you're going to learn this next year. That's what we call vertical angles. So this angle and this angle are the exact same. All right, so that would mean the right angles are the same. So that would mean this angle and this angle are the exact same. So now that we've labeled our angles, now we can go ahead and redraw our triangle. So I'm going to redraw the big triangle so it looks like the little triangle. All right, here's my right angle. Okay. And let's see here. So this would be my single line based upon my little triangle. I'm just going to redraw it the exact same way. And that would be my double line. So the side that goes between the right angle and the double line, I'm going to label that 1.8. And I guess the one between the right angle and that, I'll label D. So now I don't need this guy anymore. All right, we'll get rid of that because that kind of distracts us a little bit. And we can go ahead and now solve this proportion. Please do that, and we'll check these two answers when you come in class. Thank you.